Example 7.4.2. This one, we're going to use the capital asset pricing model to estimate a stock's required return and then compare it to its expected return. If you haven't already watched the video for example 7.4.2 that has a much longer title, something like diversification, beta, required return, capital asset pricing model, and example 7.4.1, I encourage you to go back and watch that one. I know it's a longer one, but it really unpacks what the part of what the capital asset pricing model is, or parts of it, the relevant parts, and then also why we care about measuring risk a different way and how the capital asset pricing model actually measures. This example is just going to have us using it, and you'll definitely want the background from either the chapter or from that video. There's nothing in the video that's not in the chapter. So if you read it, you're probably good to go. But you'll definitely want the background from one of those places for this problem to make a lot of sense. The calculation is relatively simple. There's just a lot conceptually going on behind it. So let's take a look at this one real quick. You are deciding whether to buy stock X. You estimate stock X's beta at 1.3 and its expected return at 10% over the next year. The risk-free rate is 2%, and you estimate the market portfolio's expected return at 8%. You are using the CAPM, or capital asset pricing model, to decide if the stock's expected return is high enough to compensate you for the risk of holding the stock. Based on the CAPM, should you buy the stock? Okay, so what's going on conceptually underneath this is we have the CAPM equation that we can just drop this information into, and what it's going to give us back is the required return for a given stock. And what the required return is this is the minimum return the stock needs to offer in order to induce the average investor to hold it because of the risk of the stock. Beta measures the risk that this particular stock contributes to a well-diversified portfolio, and this required return is the minimum return that will compensate the investor for holding that risk. So we plug in this information into the capital asset pricing model. The risk-free rate is 2%. The beta was 1.3 for this stock. The expected return on the market was 8%. And then again, the risk-free rate is 2%. We're careful to do the subtraction first, so we follow order of operations since this is in parentheses. We multiply beta times the market risk premium and then add the risk-free rate to it, and we get a required return of the stock for the stock of 9.8%. So we want to now take this required return and compare it to what we think it's going to do. And the problem told us that we've run some analysis, and we had the stock as an expected return, we've estimated at 10% over the next year. So the minimum return that we would need to expect in order to compensate us for the risk of holding the stock is 9.8%. We expect that the stock is going to return 10%, which is greater than the minimum, so it's offering us a little more return than we would need just to compensate us for the risk. So there's a little bit of extra in this for us. This looks like an attractive stock, and we would want to purchase it. If, on the other hand, we estimated the stock's expected return was, say, 5%, that would be less than the 9.8%. The stock would not be offering enough expected return, to compensate us for the amount of risk we would take on by adding it to our portfolio, and we would not want to buy it. So that's how we use the capital asset pricing model. We'll calculate that required return, and then we'll estimate the expected return on the stock, and we'll decide whether or not this looks like one we want to add to our portfolio or not based on how the expected return compares to the required return. If the expected return is higher than the required return, great, looks like a bargain, we should buy it. If the expected return is lower than the required return on the market, then it's just not offering enough return to compensate us for the risk, and we would not add it to our portfolio.